This video will focus on the quantum model, this thing that we progressed to in class. Okay, essentially, what our goal is to figure out where the electrons are in any given atom. In 8th grade, you drew concentric circles and you put dots on rings, and those dots represented the electrons, and the rings represented what energy level the electrons were on. This is not that different, this particular unit, except instead of drawing concentric circles and putting dots, we learn how to put electrons into orbitals. Okay, so the difference with Schrodinger is that we don't have orbits or rings, we have orbitals where electrons tend to reside, and that's the new thing. I'm going to teach you part of the rules of the game today. If you don't understand quantum mechanics, you don't need to understand this. And there's certain aspects you just need to memorize and be able to apply, and when you guys come back together for class, that's when we're going to apply it. So I already introduced the idea of an atomic orbital, right? The orbital being a region in space where the electrons reside 95% of the time. I told you that Schrodinger did not get rid of energy levels, right? Bohr model is amazing because it tells us about energy levels, and those exist in the Schrodinger model as well, okay? Number one, electrons are on energy levels. But within each energy level, what he found was there were what we call sublevels, okay? Areas where the electrons tend to reside, those atomic orbitals. So the atomic orbitals are essentially sublevels or locations where the electrons tend to reside per energy level. So there's a principal quantum number, or the first thing that tells us where our electron is the principal quantum number, the n. And how I like to think of it is essentially we're going to map every electron, we're going to give it all an address. Okay. The first thing that you may know about the address is what state you're in. That gets you more specific than like an entire country. And then eventually you'll know what street you're on, which gets you very specific, but until you know the house number, you can't know where the electron is completely. The principal quantum number is like telling you this state. Here's the general region where my electron resides. It starts to define how much energy it has. But then the next designation that we need to know is what orbital it's in. Okay, because it turns out for every energy level above 1, so 2, 3, 4, and up, there are multiple sublevels, as I've mentioned, per energy level. So number one, the energy levels don't go above 7 just because of the constraints of our periodic table, but in those ones that are not the first one, okay, the first one only has one orbital shape or one sublevel, but 2, 3, 4, 5, 6, and 7 have multiple sublevels, okay, and those sublevels are the orbitals. Here's a picture of what the orbitals look like. There's 4 main groupings of shapes, as you can see here. There's the S shape, which is the first spherical one, P shape, which is those yellow ones, D shape, which are the blue ones, and then the F shape, which are the green ones. Okay. What you have on your screen are orbitals. That's what they are. Now, the difference between the P and the D are that they have different energies. They're different probable locations electrons tend to reside based on the energy of the electron. Now, why the P has 3 different shapes, right? There's 3 different distinct yellow shapes on your screen, is that within the P sublevel, that P orbital, there's actually 3 locations where electrons tend to reside. They're all at equal energies. So we call that degenerate orbitals. Okay, they're all the same. They have different orientations, but that they have multiples per sublevel. So the P actually has 3 orbitals in that sublevel. The D has 5. The F has 7. Let's look at each one now. So the S orbital shape can hold 2 electrons. Okay, it only has 1 orbital shape within that sublevel, 2 electrons. That S shows up on every single energy level we see. So 1 through 7 all have an S shape. So the way it's denoted, if you look at your screen, is we say we have a 1s orbital, right? On energy level 1, we have an S orbital. Or we can have a 2s orbital, again, energy level 2, now we have an S shape. That means there's a 1s, a 2s, a 3s, a 4s, a 5s, a 6s, and a 7s orbital, all potentially in an atom. What's the difference between all these different orbitals? The size. Okay. The bigger your energy level, like 2 to 3 to 4 to 5, the bigger the sphere becomes. So 1s to 2s, the difference obviously is in energy. The 2s is a higher energy level. The 2s is a higher, more energy electron, and it's also bigger. The p orbital shapes, if you look at these are like the dumbbell guys. but within the p sublevel, there's actually 3p orbitals, 3p orientations. They all hold the 2 electrons, same as the s does. That means the p sublevel can hold a total of 6 electrons. P sublevel doesn't show up until you're on energy level 2. So we have a 2p, a 3p, a 4p, a 5p, a 6p, but we never have a 1p. The energy level, or the sublevel p, does not show up on energy level 1. For D, we have 5 potential orientations, 5 orbitals within that sublevel. Each one now holds 2 electrons for a total of 10. D doesn't show up until the sublevel 3. So again, we don't have a 1D or a 2D, but we have a 3D, 4D, 5D, etc. F has 7 for a total of 14 electrons, and this one doesn't show up till 4. So no 1F, 2F, or 3F, but we do have a 4F, 5F, 6F, etc. This screen pretty much sums all of this information up. So depending on your energy level, there's a different number of sublevels. Okay, energy level 1 has 1 sublevel, and it's an S shape. It holds 2 electrons. The second one has 2 sublevels, an S and a P, for a total of 8 electrons, right? 6 in the P, 2 in the S. 3 has 3 sublevels, SPD, total of 18 electrons, and then F has the 4 sublevels for a total of 32. Okay. This is what you need to have memorized. This is what we need to be able to use. We need to know when there's an S and when there's not an S, when there's a P and when there's not a P. I'll help you figure out how to use it. I just need you guys to have the information. One other thing I thought I'd give you on the video, just because then you can write it down, is this way of counting, right? The energy level squared tells you how many total orbital shapes you have. So if you're on the second energy level and you square it, there's 4 total orbitals, 1 S and 3 Ps. Okay. If you want to figure out total number of electrons, then just times it by 2, because there's 2 electrons per orbital. That's it. That's all you need to be able to know walking into class when I see you next. From here again, we'll show how to use this to start to map where your electrons are. Go ahead and do the form and have a nice night.